Yes, I welcome you all for the data structure class. So last class in the interaction class I disclaimed how you are performing the deletion in the doubly linked list. So today we'll see how you are performing traversing in the doubly linked list. So there are two ways of traversing. One is displaying all the node values and one is searching the node in the specific node and displaying the value. So how we are performing display the all, first we'll see with how we are performing the displaying the nodes of a doubly linked list. Okay. So as you know, the doubly linked list we can perform two ways, either in forward direction, either in reverse direction. So as you know, it is having both r link and n link value. So main thing advantage is that we can go forward and we can come backward or reverse direction. Okay. So if you go on moving to the r link value, shifting to the next node, so we found the forward direction, we display values. Similarly, if you go on to display from last to first, at that time we go on searching from last node l link value, we go on checking for the until the first long l link value we can display in the reverse direction. Okay. So next, if you want to display from forward direction, how you can start? We start with what? The first node. First node we start, then we visit the second node, third node and last node. Okay, and we display the result until the r link value becomes null. Okay, as you know, this is in the forward direction. Okay, in the reverse direction, what happens? We need to reach to the last node. Okay, first we display the last node value, next we check for the l link previous node value, then we visit the previous node, like this way until we get the l link value null. That is the first node you are having a link value null, so you can display the data in the reverse order. Okay, so this is how we are performing the displaying. Next, this is for displaying either in forward or back reverse direction. Next, if you want to go for the searching operation, what happens? So we are visiting each node. If the data is present, we return value is what? Search successful. If data is not present, we are returning as search is unsuccessful. Okay, this is about the doubly linked list. Next, about the circular linked list. So as the name suggests, circular linked list, everything is same as the doubly linked list. Only thing is that the last node r link value is null in the doubly linked list, whereas in circular linked list what happens? You are storing the first node address in the r link value. In the first node l link value, you are having a last node address. So this is the difference between the doubly linked list and the circular linked list. Okay. So again, what is the advantage of circular linked list? That we can move directly to the last node from the first node, because we are having a connection in the through L link. So that is the main advantage of circular linked list. Next, we'll see how we are performing insertion at the circular linked list. See the algorithm here. First, what to do? Again, we are creating the temporary node. Next, we are storing the data in the temporary node. Next, what do? We link the new node to the starting node. And next, what do? We store the starting address in r link value of the new node, that is temporary node, and we store the last node address in the l link value of temporary node. Next, we shift the start to the new node, that is the temporary node, then we increment the count list. See here we are having example here 10, 20, 30. So this is the circular link you are having. So I are creating one more temporary node with the value 50. I want to add here. So what happens here? I'll be storing the r link value is what? This first node 10 address I'll be storing here in the r link. In the l link, what I'd store? The 30th address I'll be stored in the l link value, and that will become what? Your last diagram here, that will be linked and start value shifted to first node, temporary node 50, 10, 20, 30. So what are the changes I'll be making out here? So here, what the code you are writing? New L link implies equal to what? Starting value of L link will be shifted to the new L link value, and the last value you are having what? The starting L link value. Next, last R link value is what? New L link value. Next, new R link value is what? Starting address, and starting address L link value is what? New node address, and start equal to new. Clear? So new L link is nothing but what? New node L link value is same as what? It will be shifted with start L link value. Previous, what is the starting node you are having? That L link node is value is shifted to the new node L link value. And similarly, last node you are storing the starting address of the L link. Okay. So here in the last address r link value you are storing the new values, new temporary node address, and new r link value you are store the previous node starting address. Okay, then starting L link value of the previous node you are storing the new node address. Okay, then what happens, your new node, your starting value you stored to as a new node. Okay, so this is how you are performing the operation. Similarly, insertion at the end of the circular list, how you are performing. Okay, see here one more algorithm you are having. So again here what you are doing, you are creating the new node, you are storing the data in the node. Okay, but here we are adding to the end of the list. So again we start with what, initial node, that is temp equal to start until the r link value is not equal to start, you go on moving to the last node. Once you found the last node, what happens, we link the new node to the last node. Okay, we store the r link address of the last node in the r link address of new node. In the last node r link address you are having first node address, starting address, so that address you are storing in new node. Okay, and first node you are storing what, the address of the new node you are storing the L link value of the first node. Okay, so this is how you are performing the operation. And see here you are given with an example here, 10, 20, 30 you are having. Okay, initially you are stored with what, here new node you are creating as 50. For 50 the link value you are adding what, and the last node value you are storing as a link value, and last node you are having r link value as new node address. And similarly the starting address will be stored as what, a link value, r link value to the newly added node. This is how the diagram will be changing. And see here you are having a, which are the things you need to apply, new r link. So new r link address, what you are having, starting address r link value you are storing as what, new node address, and starting address L link value is nothing but what, your new node address you are storing, and last value r link you are storing as what, new node address, and new node L link address is nothing but what, the last node address what you are having, that you are stored. Okay, so this is how you are performing the operation. Okay. So what is the change you are finding? It is same as a doubly linked list. Only thing is what, in the doubly linked list you are having no circular fashion. Here you are having last node address is not null, it is storing the first address. So when you add the end node, there you are the last node r link value you are storing the starting address of the node, and L link you are storing the last node address of the previous node. And in previous node r link you are having a starting address, so that will be removed. No, you are having r link address as new node address. Okay, in new node address r link value you are storing the starting address. Okay, and in the starting address L link value you are having a last node previous value you are stored as the address L link value, but now you are in the starting node L link value you are storing the new node address as a L link address. Okay, this is how you are performing the operation. Okay, so in the next class we'll see with how you are performing the deletion in the circular linked list. Okay, thank you.